All right, we are doing a little more factoring today. So some of it's review and some of it's new. And so again, greatest common factor, trinomials. And today we're looking at sum and difference of cubes. So we learned that in pre-cal. We want to make sure that we remember that. And also we're looking at some rational exponents. So we know we can have exponents like x squared and x cubed. And if we were to multiply those together, the base stays the same and we get to add the exponents. Well, it also works when we have negative exponents. So if I have x to the negative 2 times x to the negative 3, the same rules still apply. We get to add those exponents together and we get negative 5. It also works if we have fractions or rational fractional exponents. So x to the 1/2 times x to the 3/2, these have the same base, and so we get to add the exponents together. 1/2 and 3/2 is 4/2, which reduces to 2. And so knowing that those rules still apply, whether or not we have integer or whole number exponents, integer exponents, or rational fractional exponents, that all the same rules apply, and that's really important. Today is practice. Factoring with rational exponents, you'll find that on your Unit 1 grid in Clever. And again, this is practice only. I don't need you to turn it in to me. Do not submit to Synergy because the answers are embedded. It's fine. There's not a ton of work to show. There's not a lot of space on the worksheet, but you definitely want to practice. It is stuff you will be tested on at the end of the unit, and so make sure you really know how to do it. This was an interesting worksheet. When you're doing this worksheet, things they factor once and then they're going to factor again and maybe even again. It's really quite interesting. They just keep on keeping on. And so make sure that you are getting your practice in. It's really, really important. The other thing to remember is that some of them might get a little tricky towards the end. The answers are there. So think about maybe doing it backwards if you get stuck. Look at the answer, the factored form, multiply it together, and see how it works that direction. And that's a great strategy when it comes to your AP testing. You know, there are a lot of multiple choice questions, and they sometimes when I was doing a practice test, I'd be like, I have no idea how to do that. But I'd look at the answers and I could do it backwards with the answers. And so it got me at least 3 questions correct by going backwards on the AP exam, looking at the answers and doing it in reverse. So remember, doing it backwards is a great method, great strategy. All right, so first, factor completely. Again, these are notes. You should be writing them down. I expect you to be writing them down. And you need to date them, title them, write directions, just like if I was next to you. Factor completely. So first, this is difference of squares. The nice thing is that you can pause the video, rewind, go back, watch it again if you need to, but definitely write these down. Show your work, show the steps. And again, just like in class, try to be in front of me. You should be a step ahead of me. This is difference of squares, meaning that this is a perfect square. The second term is also a perfect square with a subtraction in between, different sign. And this is going to come up a lot. So definitely important to recognize difference of squares. We can double bubble that. X squared times x squared is x to the 4th, and positive 9 and negative 9 gives us negative 81. Now, sum of squares does not factor, so that one's going to stay x squared plus 9. But once again, we have difference of squares. So this one is going to factor further. And that's the goal today. You're going to see lots of things that factor one time and then they need to be factored again. And this is factored completely. Down here we have x cubed plus y cubed. This is sum of cubes. And the way that I've done this one is that it's in a very easy form to recognize because they are cubed. That's very simple. We did this a long time ago now, but it also factors. It's a nice little pattern, much like our difference of squares, but we factor it in small bubble, big bubble. Small bubble, big bubble. These signs go keep the sign, change the sign, always positive. Keep the sign, change the sign, always positive. And the nice thing is when you plug in the signs first, you don't have to worry about positives or negatives anymore. It's done. And so then we just need to look at our first term here, and we want to ask ourselves, hey, what is being cubed? And in this case, it's really easy. X is being cubed. But if your leading term was like, I don't know, 8x cubed, well, then we'd have to ask ourselves, what is being cubed to give us 8x cubed? So you need to know what's the base that we're going to cube. What times what times what gives me 8x cubed? Well, that's going to be 2x. 2x times 2x times 2x is where we get the 8x cubed. This is the base, and this is what goes in when we factor. So we have our base of x. Here, y is being cubed, so that's our base of y. Once you have your first bubble, the binomial, done, getting the trinomial here, the big bubble, is super easy. It is squaring the first thing. X times x is x squared. We multiply in the middle. Y times x, or x times y, is xy. And then we square the last thing. So y times y is y squared. Square the first, multiply in the middle, square the last, and you're done. It's important to realize that this trinomial will never factor further. You're done. If you were to try to solve it using, say, the quadratic formula, this wouldn't be a y, it'd be a number like 8 or something like that. Then you would use the quadratic formula. That's going to give you an imaginary solution. So keep that in mind. It's never going to factor by hand. All right, over here we have difference of cubes. Difference meaning subtraction, and perfect cubes on either end. So again, it factors small bubble, big bubble. The signs are the same. Keep the sign, keep it, change it, always positive. Minus, plus, plus is what I remember versus plus, minus, plus. If you know the signs, then it's really easy. What is being cubed? X is being cubed. Here, what's being cubed? Y. Square the first, multiply in the middle, and square the last thing, and you're done. That's it. So you can see it goes really fast when you know the pattern. Letter D is an interesting one. It is a trinomial that is quadratic in form, meaning that it factors double bubble, just like before. And then we can ask ourselves, hey, what times what gives me x to the 6th? Well, x cubed times x cubed gives me x to the 6th. And then last times last has to be negative 8. Negative 8 and positive 1 give me negative 8. And when I check the rainbow, that's going to give me 1x cubed plus a negative 8x cubed, and that's going to give me my middle term, negative 7x cubed. So I know I did it right. The question is, am I done? And no, I am not done. I have right here difference of cubes. So that's going to factor small bubble, big bubble. The signs go minus, plus, plus. And I'm going to ask myself, what is being cubed? Here is an x. What cubed gives me 8? 2 cubed gives me 8. And then I can square the first thing. X times x is x squared. We're going to multiply in the middle. 2 times x is 2x. And again, we've already taken care of the signs. So when you multiply, don't think this is negative 2 times x and that you have to put a negative 2 in here. We took care of the signs. So ignore them. That we are just looking at the actual whole number, not the integer -2. So, and then last times last, 2 times 2 is 4. And that's it. If you don't believe me, then you can multiply this together. Distribute your bubbles together and see that in the end, a bunch of things will cancel out except that -2 times 4, which is where that -8 comes from. On the second bubble, again, this happens to be sum of cubes. So again, it's going to factor small bubble, big bubble. And in this case, the signs are going to go plus, keep the sign, change the sign, always positive. And again, I'm asking myself, what is being cubed? X is being cubed here. This is 1 being cubed, so that's 1 times 1 times 1 is still just 1. Square the first thing, multiply in the middle, and square the last thing, and that's it. You can see this is a great example of one that just kept on factoring, and you've got a lot like this today. So we're really integrating a lot of different things all in one. All right, example 2, factor completely. And again, if you need to pause the video to write these things down, that's what you can do. It makes the video shorter from my end, which is kind of nice. And for you too, but feel free to pause the video and write down your examples here. So here we have an example of rational fractional exponents. And it's important when you look at this, like it looks kind of busy, but you need to take a step back and sort of really ask yourself, well, how many terms do I see? And you can see we have 1, 2, 3 terms here. And when I underline them, I think it's helpful for us to kind of visualize, well, now that I see clearly I have 3 terms, what do they have in common? Because this is where greatest common factor is so important. And I see I have a y and a y and a y. I can take out my lowest power. So this is y to the first. I can take out the lowest power. So I'm going to take out that y to the first power. Well, I also see that I have an x and an x and an x. So now the question is, what power can I take out? Well, the same rule applies. Even if it's an integer, even if it's a rational number, the same rules apply and the same concepts apply. So if I can take out the y because it's the lowest power, then I can take out x to the 2/3 because it also is the lowest, smallest fraction. 8/3 is bigger than 2, 5/3 is bigger than 1, and this is less than 1, so it is the smallest. So we're going to take out x to the 2/3 from each of these. Now let's see what's left behind. This can be kind of complicated. We are undistributing. In other words, we are dividing. So I'm going to just do 1 over here on the side. I am actually dividing out x to the 2/3 from each term. Well, let me show you what that looks like. We're taking x to the 8/3. Whoops, that's supposed to be a 3. X to the 8/3, and we're actually dividing out x to the 2/3. That's what a greatest common factor is, just dividing things away. Well, here we're dividing. They have the same base, and the property, exponent property, says we get to subtract the exponents. 8/3 minus 2/3. And so that gives me x to the 6/3. So that's what we're doing. We are subtracting our exponents. But another way to think about it is, well, x to the 2/3 times what gets me x to the 8/3. I'm going to keep it green here. Well, 2/3 plus 6/3 would give me my 8/3. And that's certainly easier to do, I think, than subtraction. And in red, y to the first times y squared gives me that y cubed. So something to think about. Lots of ways to do this. You can subtract or you can think in the multiplicative sense. All right, in green, I have x to the 2/3 times what? X to the 3/3. 2/3 times x to the 3/3 gives us that 5/3. Thinking about it, x to the 2/3 times x to the 3/3 gives me x to the 5/3. We add those exponents. That's the property I'm using here. Y to the first times y to the first gives me y to the second. And then I have in the last term here, x to the 2/3 times 1 gives me x to the 2/3. And y to the first times 1 gives me y to the first. So you can walk it through like that. There's lots of ways to think about this. Let's see. So this reduces. 6/3 is 2. Again, 3/3 is 1. And 1 times 1 is 1. So this is fully factored. And that's kind of interesting. This looks a lot prettier, doesn't it? And that's sort of the power. We're going to do this a lot in calculus, so it's sort of important to be able to simplify things, look for the greatest common factor, and clean things up. It's going to make one thing easier, and the whole process then for everything else will go a lot better. So now you can see we've got rational exponents that are also negative and positive. And well, it just makes things a little more complicated, but the idea is the same. To get started here, I want to look and ask myself, well, how many terms do I have? There's a term, 3 terms. And then we want to look for what they have in common. Well, I can see that I have an x to the negative 2, I have an x to the negative 3, and another x to the negative 3. The same rule applies. What is the lowest power that they have in common? And I know you're thinking negative 2. But think about your number line, because that's not the lowest. Our number line has 0, and then negative 1, and negative 2, and negative 3. Anything to the left is lower. So negative 3 is the lowest power that we're going to take out. All right, let's look at those y's. I have y to the negative 1/2, y to the 3/2, and again a y to the negative 1/2. Well, obviously negative values are going to be smaller. So again, I'm taking out the smallest power I have, which in this case is x to the negative 1/2. All right, let's see what we've got. When I undistribute those. All right, x to the negative 3 times x to the what gives me negative 2. Oh, well, that's x to the first. Negative 3 plus 1 gives me negative 2. All right. Again, we are dividing. We're taking x to the negative 2 divided by x to the negative 3. If I use my subtraction property, that's negative 2 minus a negative 3, which turns into x to the first power. So however you think about it, either option works. All right, y to the negative 1/2 times 1 gives me y to the negative 1/2. Well, that was nice. All right, let's see. Then I have x to the negative 3 times what gives me x to the negative 3? 1. X to the negative 3 times 1 gives me x to the negative 3. That was easy. Here, y to the negative 1/2 times y to the what gives me 3/2. Negative 1/2 plus 4/2 gives me 3/2. Negative 1/2 plus 4/2 gives me 3/2. So that makes sense, and that's nice. It cleans up. And then we have here, I have this 3. Well, I need that 3. And what about the x's? X to the negative 3 times 1 gives me x to the negative 3. Y to the negative 1/2 times 1 gives me y to the negative 1/2. So that's nice. Let me clean that up, see what it looks like. So that's our greatest common factors there. This cleans up to just be x, 1 times x. Here we have 1 times y squared. And this is 3 times 1 times 1, which is just 3. And again, for now, this is the first time you've seen something like that. So I wanted to introduce it. We would have done it at the end of last school year a little bit in preparation for calculus, but I just was like, I'll just introduce it here. It's fine. So get a little practice with that. We've got some time before we really need it. But again, thinking about greatest common factor is something always needed with that greatest common factor. All right, ladies and gentlemen, please go to your Unit 1 grid and get that factoring with rational exponents worksheet right below the notes. And again, you do not need to submit it. Just practice, please. Practice, practice, practice. Have a great day, you guys.